It's my pleasure to introduce Professor Dagomir de Groot, who is an associate professor of environmental history here at Georgetown. His first book, The Frigid Golden Age, was published in 2018, named by the Financial Times as one of the best 10 history books of that year. His new book, Ripples on the Cosmic Ocean, published by Harvard University Press and Penguin, is a Scientific American, New Scientist, and Nautilus book of the year. He publishes equally in historic and scientific journals such as Nature and the American Historical Review. He is editing several books on past climate change, including the Oxford Handbook of Resilience in Climate History. He writes for popular audiences as well, including the Washington Post, Eon Magazine, Conversation, National Geographic, and he narrates and produces the Climate Chronicles, an award-winning podcast and website on the history of climate change. He has shared his unique perspectives in the past with policymakers, corporate leaders, journalists, many cities from Wuhan to Washington, D.C., and we were lucky to have him share his experience with us today. So please, let's give a hand for
Yeah, it's awesome to be here. It's my first time actually on the Capitol campus. I'm kind of embarrassed to say that since I guess I'm part of Earth Commons, so I should actually be here all the time, but that has not been the case. And it's beautiful. It's so much nicer than I expected. Last night I was in New York City. I was giving a talk at a planetarium. There was also an anime exhibit. A couple of you guys know, an adult anime exhibit. I wasn't sure if it was like anime for adults or like adult anime. It turns out just anime for adults. But very unique experience. Also means I got almost no sleep at all last night, and I am in a state up here right now. So I'm very excited. Have a little bit of coffee, and also, of course, to share with you some of my research, some of my work in resilience to climate change. And actually, it's going to sound maybe a little bit strange, but it's resilience in the history of climate change before industrialization. Which is, I guess, if you're not sort of in this field, it's going to sound a little bit odd, but I'll explain what I mean in just a few minutes. Okay, so this crowd is a little unique. I've got 3 laptops here and like 6 different screens. So this is also a unique experience. There we go. This crowd, it's a little bit of an odd crowd in the sense that I don't have to really introduce some of the things I normally do, but I still will anyway. This is a visualization of climate data that's coming in all the time, real time. You can see the data from weather stations on land in red, and you've got data from ships in yellow. There's all kinds of climate information coming in, of course, all the time from what we call instrumental sources. Right? So weather instruments. Tons and tons, more data than we know what to do with, right? And these instrumental sources spread across enough of the globe that from the late 19th century, we can create what we call climate reconstructions like this one. Reconstruction is just a visualization of climate change. So we've got maps where the blue colors represent colder temperatures, the redder colors represent warmer temperatures, and they're amazing maps and graphs for terrifying a popular audience because, of course, the world is getting a heck of a lot hotter, especially in the last 20 years or so. And this map goes up to 2019. Obviously, as this crowd knows, if you took that up to 2026, the reds would be redder still, and we are now at about 1.4, maybe 1.5 degrees Celsius hotter than the late 19th century pre-industrial average, right? So students always wonder, well, why do these reconstructions start in the late 19th century? And the reason is, again, the instrumental sources that are used to create them they spread enough across enough of the world by the late 19th century that we're able to create these global reconstructions only then. But what happened before the late 19th century? Well, that's what we use paleoclimatic proxy sources for. And I'm looking right now at a paleoclimatologist in the back row, and I couldn't be happier that we finally have a paleoclimatologist on campus. It's the first time, really, that I've been able to say that in a talk at Georgetown. Sorry, May, to put you on the spot, but I'm just so thrilled that you're with us. But it also makes me a little bit nervous when I talk about proxy sources, because I know there's a real expert in the room. So don't make eye contact with me as I go through this. Proxy sources. Proxy sources from what we call natural archives. A natural archive is some part of the world's environment that can tell us how climate changed, because climate change actually affected the growth and development of that part of the natural world. And we've got many different natural archives. This is a map that I love. It's from an article that we published a few years ago, and it shows where just 8 different common kinds of natural archives have been accessed, have been acquired by what we call paleoclimatologists and climatologists of the past. And you can see this is a huge effort, a huge undertaking, because knowing what happened before the late 19th century is super important. It can tell us whether global warming is really a totally anomalous thing. It can give us an indication of why global warming is happening. It can tell us how vulnerable ecosystems actually are to changes in temperature, right? If they've endured really hot temperatures before, maybe they can survive what we're throwing at them right now. People like me, it's super important also, because knowing how climate has changed in the deeper past, before the 19th century, can give us an indication of whether human history has been affected by changes in the natural world, and maybe even can teach us how people tend to respond to shifts in temperature, precipitation, or other climatic conditions. And that's been kind of the focus, I guess, the last 15 years for me. Okay, so to give you an indication of how these natural archives work, controlling multiple different laptops here, we can zoom in on the natural archive of the world's temperate forests. And before May arrived, we actually would invite paleoclimatologists to campus. We should probably still be doing that. Paleoclimatologists in this picture who focus on trees. They're called dendroclimatologists. And you can see one of them here tampering with a tree that we used to have on campus and is now gone. Hopefully there's no relation. Her name is Valerie Truitt, and she's with a group of our students. And she's about to core into that tree. So that means you're drilling into the tree and you're extracting a really long cylinder coffee. Thank you so much. This is so appreciated. Thank you. That looks like this. So you see a couple of our students drilling into the tree and having acquired a core. The student on the right is Emma Moswild. She was my first PhD student. She now has a job at Elon University, unfortunately named these days. Nevertheless, it's a job. She's a tenure track professor. And on the far left, you can see Valerie Truitt with one of our undergrad students with one of those cores. This is in the Jesuit cemetery. So there were security who came to ask us what we were doing. Actually, I guess technically not allowed to tamper with anything in the cemetery, but we did. And when you actually look at one of these cores, you can see that there are lines, right? So these are the growth rings in the trees, and they exist because the trees have growing seasons, right? In temperate forests, trees have growing seasons. And at the beginning of a growing season, it's almost like the cells that are added under the bark of a tree are excited to be growing. They're growing fast, eagerly, so their cell walls look very thin. But then as the growing season moves on and you get to the end of that growing season, the cells are tired, much like myself, and their cell walls are very thick and they look kind of stumpy and dark. And so that accounts for these growth rings that we see in trees. Now, trees will grow for many different reasons, but one of them is the temperature, depending on where you look, of course. And another condition might be the precipitation, so how much it's raining. So the growth rings in trees it's an indirect indicator of temperature or precipitation. That part's really key. It's indirect. It's a proxy, right? It's not an actual record of what happened to the climate. It gives us an indication of what might have happened. So one of the first natural archives that was used were these forests, actually around the desert in arid parts of the world, where the trees are very sensitive to precipitation. And paleoclimatologists would use the width of these rings. And now we've got all kinds of different ways of extracting information from tree rings. And we can use tree rings, honestly, to find all kinds of crazy stuff, like solar storms in the deep past, maybe even supernovae, but also we can use them to understand changes in temperature and precipitation, looking deep into their cellular structure, looking at isotopes in these tree rings. Okay. What people like me do is supplement our natural archives with societal archives. So we'll go and we'll find lots of different textual sources. For example, a societal archive is something that's actually made by people. Textual sources that might describe weather directly, or these textual sources might describe activities that we know must have been profoundly impacted by weather, like the harvest, like when you're harvesting your crops, or when you're able to use a port or a canal, right? If a canal is frozen over, you can't use it. So, or when you're able to go to war, right? So societal archives can give us an indirect indication of weather, but they might also describe weather directly. These are images from a massive project to actually extract weather data from documents in Imperial Chinese history. And I know there's a lot of graphs here. I guess, so the brown graph on the bottom just shows the number of records. And you'll often see with societal archives that that number sort of explodes in the last 5 centuries. This is partly because of the printing press. It's also because governments are getting more and more capable. So they're more and more capable of actually collecting information and storing it. But in general, our societal archives get better and better as we get closer to the present. And then, if we're very ambitious, we'll quantify the qualitative descriptions of weather in those societal archives, usually kind of in a pretty embarrassingly simple way. But we might also try and calibrate with quantified weather information in societal archives with instrumental weather and climate reconstructions, which is what they did for this project. I have worked a lot with this source. I mean, a lot with this source. I have looked through thousands and thousands and thousands of pages of this particular kind of source, which is a ship logbook. Ship logbook is like a diary kept aboard a ship. And sailors would write this diary as they started to leave known locations on the coast. This is because they had pretty much no idea where they were. They didn't know how to calculate longitude, so they had to guess. And a way of guessing was to estimate the impact of wind direction and velocity on their journey. So sailors would keep basically a diary entry for every day they were on their ship. And that diary entry would always mention, almost always mention, the direction and velocity of the wind. And this information has been quantified partly by me. This is a database with 52 million data points, all built using ship logbooks. I'm just scrolling through it to show how much stuff there is. And this is a map of individual entries from ship logbooks. We see about 300,000 individual entries in this map. This is from 1750 to 1850. And this is a project I'm working on right now, but we can actually turn that into maps like this, where you can see how prevailing winds are changing over time, in this case from 1750 to 1855. So if you see an arrow there, that means the winds are blowing more commonly from that direction between 1750 and 1850. So there's been a trend towards more winds from that direction. I kind of love this kind of research because it's extending our knowledge of the climate back before the advent of instrumental sources, and in this case, telling us things about atmospheric circulation before we really started messing up the climate with our greenhouse gas emissions. That's important. Gives us a sense of the baseline of atmospheric circulation, so it helps us to understand how we're wrecking everything now, basically. But also, it shows us how conditions changed in ways that matter to people in the past. I think matter to people in the past. So the natural archives can allow us to go very far back in time and give us graphs like these. I love graphs, so my apologies. I love to show graphs. I understand it's not for everybody. At the top, though, is a really important graph that we probably all know what it is right away. It's a graph that shows concentrations of carbon dioxide in the atmosphere. Right? And we get this from the little bubbles that are trapped in ice. You can dig cores out of the ice and get information about the composition of the atmosphere from those bubbles. Obviously, things are not really where we'd want them to be, obviously, right? But we probably all know that. This crowd knows this graph very well. On the bottom is a graph I am super proud of. We published this a few years ago. The bottom graph shows us temperature anomalies over the entire history of our species. And that's why I love this graph, because we've been around Homo sapiens for about 300,000 years. And when this was published, at least, it was the only graph that showed us how temperatures changed specifically over the history of our species. But as my students have pointed out, it is a bit confusing because in this graph, we're zooming in as we go from left to right. So it's like, if I had a laser pointer, I would point. So one thing I don't have. For the first 2/3 of this map, that's like 300,000 years. And then we zoom in, and you'll see like a 20,000 year period that occupies another section of the map. And then finally, you'll see a little very squiggly part, right? Like a little squiggly tail on the far right. And that is the last 2,000 years. And that I can zoom in on with this reconstruction of just the last 2,000 years. And this is created using both societal and natural archives, and it's for the Northern Hemisphere. And I love it because it uses the Ed Hawkins warming stripes representation. So you can see, yes, the last few decades have been warmer than we would like, obviously, but you can also see that there's been real variation even before greenhouse gas emissions started saturating the atmosphere, right? And for people like me, for simple historians, that is very exciting because now I can see that the Earth is not just a constant place, it's a variable place, and that I think, impacted human beings. Even before greenhouse gas emissions, I think climate change has affected human activity. Natural archives can also tell us something about the causes for these variations in climate. So over the past 2,000 years, two important causes have been explosive volcanic eruptions. You need a really violent volcanic eruption to launch sulfuric gases all the way up into the stratosphere, where they interact with water molecules, create dust that scatters incoming solar radiation and can actually cool the surface of the Earth. So this has happened repeatedly and is largely to blame for those old bars in this graph. But then there's also probably a meaningful impact of small changes in solar output. So this is still kind of controversial, but at the very least, those small changes in solar output, what we call grand solar minima, correlate with many of the coldest decades of the past 2 millennia. And there's really interesting research now that's coming out showing that maybe there's a solar influence as well in the period before the year 1 CE. So all of this work that has reconstructed climate and reconstructed why climate has changed enables the field that I've called the history of climate and society, or history of climate and society studies. And this is a scholarship that tries to figure out how climatic changes and short-term anomalies and regular variability actually mattered for human history, how it impacted the human past. This is a collage of books that took so much longer to make than it should have. But I try and update it regularly, and it never looks any better. But nevertheless, it shows books by historians written about climate change and specifically the Little Ice Age. And it's kind of embarrassing that I put my own book pretty much in the center. But you'll see that there's also many other recent books. Very recent books here include The Earth Transformed at the far left. The Price of Collapse. The Earth Transformed tries to tell the whole story of climate change, and it kind of sucks. But you'll see The Price of Collapse on the bottom, which is about the fall of the Ming Dynasty. I think it's much more interesting. So it blames drought for the collapse of the Ming Dynasty in China in the early 1600s. There's also a really cool one, which I haven't read yet, which is beside the red book on the top right, which is also questionable. But beside that, you'll see New Under the Sun. And this is about climate in Palestine. I'm very excited to read that book. I'm embarrassed to say that even though I put it on this collage, I have not yet read it myself. But point is, there's a lot of scholarship being generated about the human history of climate change. In fact, I put together this graph for another publication, and it shows the number of publications published in this field or related to this field since the 1970s. And you can see there's just been a big increase in the number of publications. Actually, even though there's been an increase in the number of publications, reality is that the publications all have something in common, which is almost all of them are about crisis and collapse. And maybe that feels fitting. But to be a little bit more specific, they focus on populations that seem to have endured horrible disasters when the climate changed. And sometimes actually the most influential publications focus on the collapse of civilization, which is when a civilization suddenly loses at least perceived complexity, right? It seems to unravel. There's a drop in population, sometimes a total destruction of the population. There's elimination of elites or replacement of elites. Sometimes settlement patterns fundamentally change. You can think of the collapse of the Western Roman Empire, for example, right? Or there's many examples of collapse. The classical Mayans, for instance, seem to have collapsed. So the overwhelming majority of the scholarship in this field focuses on disaster. What I've tried to do in my career is focus instead on resilience, the ability of societies to endure, to cope with a hazardous event, trend, or disturbance, responding or reorganizing in ways that maintain their essential function, identity, and structure. This is an IPCC definition of resilience. And I want to emphasize that this definition, therefore, includes the ability of a population to bounce back after a catastrophe, to resist damage when the climate changes, or even to adapt itself quite fundamentally, but not in ways, right, that cause the population to lose its identity. And as you can probably imagine, this kind of concept is controversial and contested, like all academic concepts, right? And there's a question of, well, what does it mean to lose your identity? Is a collapse therefore also resilient because you've changed? So there's a whole huge debate about this concept and whether you can even use it, which I'm going to be sidestepping entirely for the rest of this presentation, but you should know that that debate does exist. So this has been the focus of my work. My first book then was about well, it's often described as being a book about resilience, but I think it's actually something slightly different. And that book is on the left. I think it's a book that's really about how climate change impacts a society. And I know that sounds very broad, but I really wanted to drill down with as rich a documentary record as I could, going beyond political changes and actually looking at things like transportation, like shipping, like military campaigns, like even the creation of maps and poetry, actually looking beyond political shifts and military upheavals. If we look at other sectors of a society that hadn't been considered before, what can we say about the impacts of climate change on a society? And it turns out you can say a lot. You can say that some people were vulnerable, some people suffered, but not everybody. And institutions were often resilient. And society as a whole was often resilient. And that's kind of the big takeaway of the book. So because of that, the book is often framed as being a book about resilience. But again, I think it's a little bit different than that. All the same, and I have not had a sip of my coffee yet. My gosh. Ooh, I needed that. All right. All the same, I went on to look more and more at resilience in different parts of the world, especially the Arctic. And I wanted to look at the Arctic because the little ice age had its biggest impacts probably on temperature anyway, and on ice in the Arctic. And so here's a pretty extreme example of environmental change. And so how did people then respond? And what I found were examples of adaptation, not just in people, but in whales. So there were whale populations that responded by altering their culture, as I would call it. And there were whalers who were hunting them, who altered their culture. And there were merchants who preyed on both whalers and whales. So there were different groups, and they're all responding flexibly, some of them in the Arctic, to a changing climate. And I just wrote a ton about these whalers. You can see the most recent publication. Whoops, no, I'm using the wrong laptop here. Good thing I have all these monitors. You can see the most recent publication on the left, and here I'm using ARC to try and trace resilient responses by whalers. And I say the price of adaptation because those merchants are the ones who are ultimately benefiting from the resilience of ordinary whalers, many of whom are paying a steep price to be adaptive. It's true that I often write popular articles, and I've written a number of popular articles on resilience in the little ice age, like this one for Eon. All the comments are negative, pretty much. Everybody is saying things like, you don't know what an ice age is, or climate change isn't happening. I had to mention something about the Green New Deal at the end of this publication, which I support. Of course, everybody was very angry about that as well. So never read the comments. I learned that with this article. If you ever publish for a popular audience, do not read the comments ever, because you will never publish for a popular audience again, or at least not for a while. I've also written some stuff for scientists. Here, actually, in this article on the left, I'm exploring why so many of us have written about crisis and collapse, and in my view, pretty much nothing about resilience, or not enough about resilience. And this one, it's kind of harsh what we go through, and we find all these sort of cognitive biases that might be to blame. And then we go through and identify different populations that seem to have been resilient. We try and see if they had anything in common. So this also gave me a kind of connection to the UN development program, which I've been contributing to since then. For this report, talking about whether we can learn something from the resilience of past communities that can help us adapt in the future. And I create the Climate Chronicles, which is my attempt to tell the whole history of climate change from like 45 million years ago to the present. It's basically a free audiobook, or at least 2 free audiobooks. So there's like dramatic music, and there's videos and stuff like this. But resilience runs through the entire production. Can we adapt? Can we learn from our ancestors? Particularly so far, our ancestors in the Pleistocene, the geological epoch that precedes our own. So I'm also doing like this handbook on resilience, tons of examples of resilience over the past 20,000 years. And we're identifying these different ways in which populations were able to be resilient, again, seeing if they had anything in common. But honestly, I'm not going to go over a lot of this stuff. Instead, for the next 15 minutes or so, I want to present some reflections on resilience after about 15 years. I don't want to think about how many years of working on resilience. And this is what a lot of the work looks like. I'm in the archive. Maybe it's not as cool as being in the field, maybe in drilling for cores, but it's probably warmer and it's probably more comfortable. And there's cool old documents that have water damage sometimes on them. These documents were created, actually written by whalers in the Arctic, which I think is just automatically cool. And you'll see a camera at the top right. I'm taking like thousands and thousands of pictures and then bringing them home. And hopefully, I'm just hoping that they're not too blurry for me to be able to read. So reflection, some thoughts on resilience. Okay, sometimes I also just go to the Zoom meetings and I talk to scientists. That is less exciting, but the best stuff is in the archive. So first, resilience is difficult to find. It's difficult to detect. And this was actually my big breakthrough when I was working as a PhD student. So I think some of you are graduate students, right? Or want to be graduate students. And I thought I was going to do my PhD on how the Little Ice Age, which I'm recognizing I haven't yet defined, the Little Ice Age is those blue bars in that reconstruction of the past 2,000 years, older temperature. So I thought I was going to write my dissertation on how the Little Ice Age brought about disasters in the Dutch Republic. I'm originally Dutch. So I thought, okay, I'm going to use my Dutch language skills to figure this out. And I didn't see pretty much any of that. And I started freaking out about, well, as I was in my second year, I think, that's when the freak out really started building. And I was like, well, I don't have anything to write about. So I'm just screwed. And, but then I had a breakthrough. And my breakthrough was that things not happening is actually more interesting than things happening. Because the things not happening indicated that the population was able to endure changes in the climate that I could reconstruct or that other people had reconstructed already. And that was very exciting. That allowed me then to move on to the next stage of the project and to interpret documents differently. So this is a graph that actually shows pretty much nothing. It's just kind of random noise. And that is often what resilience looks like. So it's in a sense, when you're trying to study resilience, you're looking for what's not there more than you're looking for what is there. And this is really challenging for a few different reasons. One is it requires you to kind of shift your mindset. The other thing is that negative results do not get published, right? So if you're looking to publish in Science or in Nature, and I'm doing this right now with a group of scholars from China, we're arguing that something didn't happen, rather than that something did happen. And journal editors hate that as a general rule. This is a big crisis, I think, in science, right? Negative results don't get published. So that skews our entire understanding of the past of, pick your science, basically, right? So resilience difficult to detect, and that can suck for scholars who are studying resilience. All right. This one may be a little bit nicer. Resilience is often surprising. And this takes me back to those whalers, right? So I was drawn to the Arctic. I started researching the Arctic. I wrote more, I think, about this part of the world, which is Svalbard, an archipelago halfway between Norway and the North Pole. I wrote more about this part of the world than probably any historian. I got obsessed with it. And that is because the relationships I expected to find there did not exist. And in fact, the opposite relationships that I expected to find in actuality prevail. So what was I expecting to find? Well, I thought that initial journeys of exploration to Svalbard in the late 16th century would be wrecked, ruined, derailed by climate change, by one of the cold waves, cold decades, cold stretches of the Little Ice Age. And then I thought that whalers who end up there were going to be, encountering terrible difficulties as a result of ice, and maybe they would even fight different whalers from different countries because of climatic cooling. And I found totally the opposite. In fact, it was heavy sea ice that directed explorers to places where whales would feed in the summer. And it was heavy sea ice that sometimes kept whalers from fighting. And in fact, the whaling industry booms in the Arctic exactly when it cools down the most in the 17th century. And I think this is probably the biggest theme in all of my work, and maybe it distinguishes my work a little bit, is that the relationships I tend to find are often counterintuitive, exactly the opposite of what I expected to see. And maybe that's because my expectations are wrong, consistently wrong every time I approach a project. That is absolutely possible. But it might also just be that I'm looking in places that other people haven't looked before, or at a resolution that other people don't look at. So like, what I mean by that is, instead of looking at grand sort of societal processes, I look at how ordinary people, actually act, how they actually think, how they live their lives. So at that resolution, sometimes I think things can be very surprising. So my experience has taught me to be very wary of prior assumptions, because at least when I'm actually doing the research, those assumptions are almost always, for me, wrong. Another thing I'll say is that I think resilience has mysterious causes. And actually, this is tied to something else that I believe, which is that I don't actually think we know what causes historical change. It's a little embarrassing, because this is the whole point of history. History is all about trying to explain why things change. That's what we do. But I don't think we have any real clue as to why things change. And you might talk about, the decisions of great people, or economic trends, or social trends, cultural trends. But which of those things is most important? And which decision exactly was the hinge on which history turned, right? Which person made that decision? Is it the powerful person, or the person who influenced that person, who then influenced another person, and so on and so on and so forth? Kind of like a butterfly effect theory of history, I guess, right? I don't actually think we know what causes historical change. And when it comes to resilience, many different causes have been proposed. So there's been articles, quantitative articles that argue, using all of these examples you can see on this map, that it's exposure to prior hazards that allows a population to be resilient. So if a population has endured all kinds of crises before, well, the next one, probably that population is going to be able to cope with. Maybe. There's also, my efforts where we identify many different what we call pathways to resilience. So different strategies that seem common to diverse populations that allowed those populations to be resilient. But I am 100% sure that we have not even come close to discovering all of these pathways. I'm also 100% sure that at least some of the pathways are influenced by our prior assumptions. So we might argue, for example, that an egalitarian population is more resilient than an unequal one, but it can't be denied that some of history's most unequal societies were also very durable, like ancient Egypt, for example, or imperial China, right? So it's really hard to know what is making a population resilient. And I do think a lot of our assumptions, or a lot of our claims so far, have been based on correlation and even conjecture. So part of the issue is a lack of a smoking gun. This is the nature of historical research. that we are especially research on climate change that is doing history. Because nobody in the past is talking about climate change like we talk about climate change now. And there are no sources, no textual sources that say something like, well, the climate is changing, and because the climate is changing, we are going to act differently. That basically doesn't exist at all for historians, which is unfortunate. But even if that did exist, we might not believe it. So we'd still have a problem. I'm very comfortable with this. After many years of working on resilience, I think that we need to embrace the uncertainty, and we need to characterize our conclusions as provisional in character. And I'm cool with that. But many historians are not. And they argue that work in climate history or the history of climate and society lacks rigor as a result. And this is something that I really found with some of my work on climate change and the conduct of war, so how war actually played out. Way back in 2014, which is either a long time ago for some of you and maybe not for others, I published my first article. And this was an article on wind direction and the conduct of naval wars in the North Sea. There were 3 naval wars fought between England and the Dutch Republic, which is the state that would become the Netherlands, as prevailing winds shifted in the North Sea region. And I've made a few of these maps, but they are maybe a little bit difficult to interpret. But here we've got different battles in these naval wars. Each battle is a circle, and the side that won the battle is represented with a little flag in the circle, and then the direction of the wind is indicated by the arrow, and the velocity of the wind by the thickness of the arrow. And I was really proud of this representation when we had it, but maybe now it's it's kind of questionable. But the point is, okay, so the winds shifted, and the Dutch won most of the battles after the wind shifted in these naval wars. Why? Well, maybe it's because the shifting of the wind allowed the Dutch to be in between the source of the wind and the English fleets. And that gave them the tactical initiative in battle during the Age of Sail. But we can't deny that a lot of other things changed as well. The Dutch started fighting with English tactics. So they're starting to sail in a line, and the line is then going towards the English line, and they're firing broadsides. If you're interested in war during the Age of Sail, this is how you would normally picture it. So they changed their tactics, they changed their technology. All kinds of things were changing. So what is ultimately decisive here? I can't tell you. I can tell you that winds seem to be correlated with changes, right, in the success of the Dutch in battle, that maybe there's a connection, but I can't tell you definitively that the Dutch won because of the winds, much less that they won because they learned how to exploit the winds to truly be resilient, right? I can't tell you that, unfortunately. And I think if you're doing this kind of research, you have to be comfortable with that. Another thing that I found and that I've had to learn and that other people have taught me, frankly, is that resilience is not always a virtue. And this is partly because the resilience of some comes from the vulnerability of others. You take the Dutch, for instance. My belief is that parts of the Dutch Republic were resilient even before the expansion of the Dutch tentacles across much of the world and the creation of the Dutch trading empire. However, it can't be denied that by the end of the 17th century, the Dutch were wealthy and prosperous in part because of their depredations all around the world, their exploitation of colonized peoples. So there is the wealth of the Dutch, which is related to their ability to be resilient in the face of the Little Ice Age, came in part from exploiting other people. And we can see a version of that also with that fall of the Ming Dynasty in the 17th century, which correlates strongly to extreme droughts, really extreme droughts. Now, the Jurchens to the north, who were later called the Manchu, also endured droughts. But then it shifted, and the Ming Dynasty, the Ming territories, endured way more drought than the Jurchens. And what we see is, when both of them endured drought, the Jurchens started invading into China, into the Ming Dynasty, and pillaging and taking Ming supplies from granaries. And therefore, that probably helped them to endure during these droughts. But ultimately, as the droughts worsened for the Ming Dynasty started coming apart. Now there were plenty of rains for the Jurchens, and now they were able to use the vulnerability of the Ming Dynasty to actually take it over and establish the Qing Dynasty. So the Ming-Qing transition is in part a product of the Jurchens being able to be resilient by plundering the Ming territory. So again, resilience for me comes at the expense of you. Right? So resilience, I think, is not always a virtue. There's also another element to this, which is that resilience tends to make systems persist. It tends to keep systems in place. And if those systems are exploitative, right, then resilience can be a really bad thing. There's a famous historian, E.P. Thompson, who wrote that stability no less than revolution has its own form of terror, right? Which means that stability can be a really bad thing if what's stable is stuff that oppresses, right? So this I had to learn from others. I do think that this is kind of complicated. I haven't fully worked it out, honestly. I think that resilience is probably the default condition for human populations in response to climate change historically. And I want to emphasize historically, and I'll get to that in just a minute. And of course, I mean, you can see this with population trends. The world's population has gone up dramatically. Even since the advent of agriculture, actually, I think this captures it quite well. There's been tremendous population expansion. We should take all demographic reconstructions with like 15 or 20 grains of salt, because we fundamentally don't actually know what human populations were doing. We can only guess. This is kind of like the proxy work I mentioned earlier. But this is pretty much our best guess right now of how populations changed since the advent of writing, so since the Bronze Age, basically. At the beginning of the Bronze Age, there were maybe 5 million people alive. So that's about 5,000 years ago, maybe 10 million. And then after, well, about 5,000 years of agriculture, of expansion of polities, we stood at about 1 billion people by the year 1800. And of course, since 1800 to the present, we've gone up to over 8 billion people, right? So fundamentally, I think you have to argue that the human default state in response to the climatic changes of the past 5,000 years at least has been resilient, at least for enough of a population to enable the population as a whole to grow. Take this with like many caveats and recognize that resilience is a very broad category and that I'm still trying to work this out. Okay, last one. I always love to end on a depressing note because I think it's sometimes warranted, but resilience by itself, I don't think can save us from the climate crisis, right? You often see representations like this one, where there's a good path and a bad path. And this is connected to representative concentration pathways or shared socioeconomic pathways, ways that we have of trying to forecast the future of climate change, right? And the top way is RCP 8.5. It's where we just burn all the fossil fuels we can, and we warm the Earth by at least 4 degrees Celsius by the end of this century. That, I think, no amount of resilience is going to be able to endure, at least not for the majority of the world's population. And bottom way, the happy path, RCP 2.6, is where we actually dramatically reduce emissions, right? And we limit global temperatures to 2 degrees Celsius or less. And we are, of course, somewhere in between these two extremes. That's not where I would like to be. I would much rather like to be in that bottom safe path. And if we are on that bottom safe path, I say safe, but of course it's not exactly a safe path, right? It's still going to be a lot of climate change that we have to cope with. So we still need to be resilient. We need to adapt a lot of aspects of how we live, right? But I think I'm confident that we can do it if we stay in that bottom path. The top path, I really don't think it will be possible for a large part of the world's population. And I will say this also gets into how the past is different from the present. This is, so I'm also creating an atlas of environmental history with John McNeil, one of my colleagues at Georgetown. And we've got these images, these brand new images of different periods in climate's history. And here we can see the Younger Dryas, which is maybe my favorite period in climate history. This is when a system of ocean currents known as the Atlantic Meridional Overturning Circulation dramatically weakened, and actually weakened because a period of rapid climatic warming, rapid global warming. And what we had is probably a huge amount of fresh water spilling into the Atlantic Ocean. And you can see it represented here with those arrows on the top left, or the Arctic Ocean maybe. It's kind of uncertain where this happened. But basically a massive meltwater lake spilling itself into the Atlantic Ocean because an ice sheet had retreated enough to make that possible. And as a result of that, the Atlantic Meridional Overturning Circulation pretty much shut down, slowed down at the very least. This is what we expect might happen. It's quite likely to happen, actually, in the coming decades. Now, when it happened during the Younger Dryas, which began 12,900 years ago, some populations of hunters and gatherers adapted really well. So tundra environments spread because the shutdown of this current cooled the Arctic and high latitudes, and hunters and gatherers pursued caribou into these tundra environments, and they actually thrived, some of them. Some of our ancestors did really well when the Younger Dryas happened. But if the Younger Dryas happened now, then European temperatures would actually collapse because this system of ocean currents gives a lot of heat to Europe in the winter. And on top of that, the monsoons would grow a lot weaker. Sea levels would actually surge off the American East Coast. Our ability to grow food would go down dramatically. And this is because, the world is a radically different place. There's 8 billion of us. We rely on these intricate systems. We have enormous coastal infrastructure, right? And so because the world is different, we can't depend on the resilience of our distant ancestors, right? And this way, the past is fundamentally different from the present. And there's a limit to what we can learn, maybe, from people who experienced the Younger Dryas. Okay. So to conclude, the past is, I think, a really underused resource for how we forecast the future, right? Our attempts to understand how climate change is affecting our society today, or how it might affect our society in the future, almost never involve history. Yet we have 300,000 years of human experiences in the face of climate change that we can draw from. And we can learn, I think, from our ancestors how to be more resilient, how to be more adaptive. But going back to that Younger Dryas example, past is also deeply flawed as a guide to the future. All ways of understanding the future are, of course, flawed. That's why we can't do it yet. But past is definitely full of problems when you're trying to do this forecasting work. And maybe what we need to do is combine that imperfect history with our other imperfect ways of forecasting the future. And that perhaps will give us a better sense of what the future might have in store. Okay, so if you're interested in this stuff and you don't want to spend any money learning it, you can go to theclimatechronicles.com. There's also no advertising. So you can listen to an audio book basically there on the history of climate change. Thank you so much. I look forward to your questions. Yeah.
So brilliant as always, very thought-provoking and strangely calming in the face of all that we're facing. So I appreciate that as well. Maybe it's the
It's
tire.
a lack of coffee.
Yeah, exactly. So I wonder if you've seen any move to reframe the definition of resilience, which is very human-centric, the way it's presented. But even though people have found ways to be resilient in the face of climate change, we're in this era of tipping points, maybe even breaking points, right? It's a kind of terra incognita that we're facing now. That suggests maybe that our own resilience is connected much more deeply to the resilience of the ecosystems that we're interdependent with. Have you seen any move to reframe the definition, which might lead us to reinterpret the past, but also mark something different toward the future so that we're not limited by the caveats that you're expressing?
You always put it so well, tipping points leading to breaking points. I'm going to steal that for sure.
It's yours.
I'll say
Public
that.
domain.
I will not cite you.
I don't even cite me. So.
Well, the concept of resilience in its modern form comes actually originally from ecology. And so this is in the 1970s even. And then that concept was applied to different disciplines like disaster studies by the late 1970s. And was immediately controversial. The meaning of that concept has actually changed over time, at least the dominant meaning. So at first it was very much focused on bouncing back and bouncing back to a kind of stable equilibrium. And then it started adding meaning basically, right? So now you have the IPCC definition for human responses to climate change that's super broad. It says everything and nothing, kind of, right? Just partly what I like about it, to be honest. But what's very ingrained, I think, in discussions of resilience, especially I would say in archaeology, much more than history, is this idea that there are coupled social natural systems, right? And that the social system depends on the viability and the persistence of the natural system. So that, I think the archaeologists do a much better job of that, honestly, than the historians. They have different sources, obviously, to work with as well. But yeah, so I guess the answer is yes, people are thinking about that very deeply. Yeah.
Hi, I'm Elisa Bucci from Theology and Religious Studies. Thank you very much for this wonderful presentation. I really have a lot of empathy for the archival sources because I work on missionary archives that are rich of information on climate change.
Mm-hmm.
I have a question about the concept of resilience, which is fascinating. But my question is, if the survival of a group comes through displacement, loss of the most vulnerable members of a group or a population, or the death of half of the population, is that still resilience?
It's a great question.
They see weather when it's winter and it's terribly cold and the temperature goes extremely low. We had horrible days in this year, last year. We were resilient, but many homeless people died.
Yeah.
So is our resilience defined in a way that ignore those who don't make it?
I think
The
so.
most vulnerable. So
Yeah.
what is really resilience? Is the survival of the fit, or if we want to engender that definition, it is the survival of the powerful member of a society?
So first thing I'll say is that we should have met a long time ago, I think, because a number of my students either work with missionary sources, my graduate students, or want to work with missionary sources. So they should probably be talking to you before they talk to me, frankly. So that's number one. And number two, this gets at, I think your question gets at a really fundamental issue in the study of resilience in climate history, which is what is in fact resilient, right? And for me, the things that come to mind, and I mentioned this actually in the Climate Chronicles, the Palisades fire in Los Angeles. As it was happening, I recorded an episode. And as I was recording, I was like, well, you know, Los Angeles is going to survive this, right? Los Angeles will still be a city in a year. And, well, obviously, people are dying, people are losing everything, their lives, their livelihoods. So does that mean that Los Angeles has been resilient? And I would say that as a historian, let's say 1,000 years from now, looking at the city, the fire would be a blip, right? And you could easily argue that at least until now, the city has been resilient, right? And I thought the same actually for New Orleans, obviously with Katrina and you know, Houston, Harvey, and all of us actually living through COVID, right? You could see resilience in every case, but resilience at the expense of so much, right? So yeah, I think if you're not careful, then resilience as a concept really paves over the suffering of ordinary people. And that is, I think, one way that you could argue, like my book, The Frigid Golden Age, right? If you argue that the book is about the resilience of a society, which again, I probably wouldn't, well, then you could criticize that book because yes, the population overall grew and the wealth of the society grew tremendously, but all along the perimeter of the society, even in the Low Countries themselves, and Low Countries is like the low-lying parts of Northwestern Europe, of course, there's devastation, right? Ordinary people are suffering in these constant wars. The perimeter of the empire, there's devastation, obviously, as you know, people are being abused, essentially, right? And being conquered. So there's just and there's like people in cities, right, who are suffering as well. So there's enormous amounts of devastation. Ecosystems are being devastated, like the whales, for instance. So all of this devastation and destruction is fueling the resilience of the institutions, of the government, of the wealthiest people in the wealthiest cities. So that's why resilience is not necessarily a virtue, but it also is why we have to be very careful about the scale at which we're exploring resilience historically.